performing a task successfully in professional and educational and other life context by three skills. Three things. One is knowledge, skills, and abilities. So the main purpose of this is just I want to give. It is away from the routine system what we are following till now. As the educational policy changed, so they want to transform the teachers from old system to new system. So how to implement this CBL in mathematics? For that purpose, KVS conducted a training for the resource persons we are presenting today at JIT Mysore, JIT Mumbai. So how to take this CBL in mathematics? That is the main concept here. Further, they identified the 5 areas. Those 5 areas, 5 days, the resource person will present to us. So before going to detail for that one, today I am welcoming all the participants to this training program. Sir, principal sir, to introduce, to inaugurate the function.
Good morning to all.
Good morning,
Honorable
sir.
Assistant Commissioner, Madam JSV Lakshmi. Today's resource persons from Kolkata region, Ms. Kusum Kumari and Sri S. Chakrabarti. Dear participants, the CBSE, you have seen many circulars that has dedicated this academic session for competency-based learning with a larger goal to promote 21st century skills, where the focus of teaching is on the outcomes that students need to acquire. Skills connected to critical and creative thinking, problem solving, collaboration, and communication. These are considered as core skills to successful living in 21st century. What is competency? Competency is set of skills, abilities, knowledge that helps an individual to perform a given task in real life. Every learning should go into the imbibing of skills that will help the individual perform tasks or take actions to lead a productive and joyful life. Several competencies are required here to succeed, and all these competencies or skills sets should also be acquired in the process of learning, schooling. Only then school education would be considered effective and fruitful. Competency-based learning or competency-based education is an outcome-based approach to education to ensure proficiency in learning by students through demonstration of the knowledge, skills, values, and attitudes required for dealing with the real life situations at the age and grade appropriate level. The National Education Policy 2020 calls for shift towards competency-based learning and education, which is an outcome-based approach to ensure proficiency in learning by students through demonstration of the knowledge. Now, term competency generally used in elementary classes, and elementary education we can divide in 2 parts. One is primary education, class 1 to 5, and another is upper primary or middle classes, we can say class 6 to 8. Therefore, what is applicable for primary classes, that is applicable for classes upper primary also, classes 6 to 8. Few months back, the same workshop, CBL workshop, was conducted for primary teachers also. Then, on the basis of feedback received about training of primary teachers, it was felt that this type of training to be given to teachers of teaching classes 6 to 8 also. Therefore, this CBL competency based learning workshop was arranged for TGT maths. Now, NEP National Education Policy 2020 also speaks about assessment of students at various levels to find out the efficiency of our education system. Not to put the labels on students or not to put labels on teachers, but to find out the efficiency of the system only. And if there is any necessity to improve it, how we do it, and for that purpose, certain assessments should be done. And how these assessments are going to be done? These assessments are to be done on the basis of previously defined learning outcomes. Learning outcomes which is notified by NCERT, that learning outcomes that a child is expected to achieve by the end of the course of each class. Then teachers need to incorporate these learning outcomes in their day-to-day teaching and learning with the students. Teaching is considered successfully only when students have attended the learning outcomes. Now, how to measure the learning? For that, you need assessment, and that assessment again should guide in further planning and assessment. Now, these days, we have started to introduce horse questions, CCT based questions, where students to actually need to think, apply their mind, use their learning, only then they can answer the questions. Therefore, here teacher-centered knowledge transfer is insufficient. Therefore, we need to move the learner-centered competency-based learning. Our task is not to transfer or share what we know, but to enable the learners to achieve some competencies so that they will become productive, successful citizens as they grow up. So if assessment of progress of students going to be made on the basis of learning outcomes, then we as teachers have requirement to ensure that our students do attain these learning outcomes. And only when they attain the learning outcomes for which the assessment is made, our students could turn out to be successful. And therefore, this program is not just to build the competency of teachers, but then it is also to take care of the statutory requirement of the country. Therefore, I request to all of you to participate in 5 days program very proactively, so that not only your competency is built, you are empowered further to build the competency of your fellow colleagues here there are 5 different aspects of teaching learning have been identified through which we can achieve and ensure that our students do attain the desired learning outcomes. It could be problem-based learning, mathematical modeling, use of ICT, development of productive assessments, these themes. So we have 5 different focus themes. Using these focus themes, teachers can design, build successful teaching learning material so that our students do attain the desired learning outcomes. We are focusing on, we are moving towards quantity to quality based education. I request you all to participate very actively. Thank you.
Thank you very much, sir. Now, I request JSU Lakshmi Madam, Assistant Commissioner, Hyderabad Region, to interact with the participants.
So good morning, all the mathematics teachers here.
Good morning.
Morning, madam.
Good morning, madam. Good morning, madam.
Morning, madam.
Good morning, madam. Good morning, madam. Good morning, madam.
Good morning, madam.
Good morning, friends.
Morning.
And the principal Kendriya Vidyalaya NTPC Ramakunda, Mr. Shravan Kumar, the director of the course, the resource persons from Calcutta region, Mr. I forgot the names, but then
Sunit Chakravarti,
Mr. Chakrabarti and another madam is also there. So,
Kusuma Kumari, madam.
one thing I'll tell you, mathematics is the most important subjects among all the subjects. Like there was one lesson in our, when I was in primary, the parts of the body. Hand is important, leg is important, this is important. All are important, of course. But then mathematics is one subject which the parents give a lot of importance, and a maths teacher definitely has a great respect in the society also. What subject you are teaching? I feel personally, English maths means English. A person who speaks in great English, oh, great teacher. If you speak in Telugu, people are not, parents especially, they want every child to speak in English and do maths well and get 100 out of 100 in maths. Yesterday, I watched this KBC, Kids Round is coming. This PISA or competency based, nothing, it's only lot of work for the teacher and less work for the student, whether the child understood or not. You know, framing a question. Yesterday, I think whether you watched KBC or not, there was one question where the child, 7th class fellow was sitting, and in a class there are 30 students, and the number of boys to girls ratio is 50-50.
1:1.
3 girls are absent one day. One boy, one girl has to be paired. How many pairs are there? That is the question. Have you all watched it?
Yes, sir. Yes, madam. I watched it.
I think it was so good, and the child was able to answer it without any helplines. Those questions, their percentages is there, application, subtraction, all types of things are there, and that is a PISA type or competency based question. So competency based questions, only thing is lot of mind work for the teacher. You have to sit peacefully in one place and frame lengthy questions. The answer is 12 and it is a 2-digit number. The number only is the answer, but your question will be 3 lines. So I feel now the present generation teacher has a lot of work and homework to do. It is not that you teach something and same numbers are given. What textbook worked out example hai, cone is cut, and then something frustum or something is formed, and same digits are repeated. Some children by heart maths. same answer they get, oh maths mein bahut acha gaya. Aisa nahi hai. It's just applicative, related to the day-to-day surroundings of the child. You should know a little bit of a maths teacher should also have good English in framing the questions. You should not frame sentences which are ambiguous and which give double meaning and all that. So I think question framing, that's what I heard our Ramagundam principal speak. Assessment is also a part of this program. In this assessment, mainly the technique of setting the question paper. Setting the questions are very important. And fourth and the last important thing nowadays, present generation, teachers of present generation. Here I could say is on the screen some young people are there, some very seniors are also there. Now the difference between younger and the senior ones, the usage of computer and typing your own questions. We should not depend on somebody. Suppose x to the power of 8. That power of 8, whether you know how to type it or not. Similarly, my subject is chemistry. The equations. I am old time teacher. 36 years back, I was a teacher. That time, we didn't have computers. We were writing on the board and children will copy, or some stencil was there. Stencil cutting, stencil duplicating machine. All that is outdated now. Who is a good teacher? A teacher should move with a laptop only. You should have a bank of questions. I think at the end of this workshop, you will give me soft copies only. Everybody type. Even old timers, it's not very difficult. We can learn. I learned many things for myself. Now I am assistant commissioner. My reports, I have to depend on some steno. No, I don't like it. So I learned it myself, how to do my own work. Our work is typing the questions. You have to do it yourself. In these 5 days, I think some group interactions are there, as I heard in the morning. In the group work, I think primary I heard, I attended similar type of workshop. They prepared so many questions. This bank of questions, send it to us also, Mr. Shravan Kumarji. At the end, whatever teachers prepare, let us have a question bank. And from question bank, suppose you are busy one day, some questions can be taken. Improve the usage of computer. And all of you are sitting at your residences, as I see your backgrounds, and you type your own things and send. One more question. In March, I attended one workshop, not virtually, physically. I went to Mumbai. Corona was at its peak. International flight without a mask, I traveled. I was thinking over because I am diabetic, that's the end of my story. But I came back safe. All foreign fellows, this side, that side in the flight. From Dubai it came, and from Mumbai I came in the same. There in international airport, they stopped me, temperature check, 1, 2, 3, 4. I was praying God that I should come out of that, because if little temperature fluctuation, they are telling, us side kade ho jao, us side kade ho jao. But I passed and came off. In that, one IIT professor, he is a physics professor. Then see, their knowledge is up to PhDs and MScs. So they are telling how to set a PISA question. They are training us also. In that he said, it is a physics related question, but you people are mathematicians, should have little physics also. Speed is equal to distance by time. That you know, or velocity is equal to distance by time. Now one boy is there in class 8th, Ram. Every day he goes to a river, just on a cycle. The river is 6 kilometers from his house. So one day morning he got up and drove his cycle, and it took for him 10 minutes to reach the river. Then he sat there for some time. He enjoys the breeze and the cool breeze like Hussain Sagar, and then he returned to his house in a shortcut route. He did not return by the same route. So the shortcut route is 4 kilometers. And he covered the distance in 6 minutes. While going 10 minutes, while coming back 6 minutes, and while going distance is how many kilometers? I said 10 kilometers. And then while coming back, while going 6 kilometers and while coming back 4 kilometers. I am getting confused myself. Then the question was, what is the average velocity of the complete journey? How do you answer? AC is also answered wrong. I want our Begumpet teacher is thinking deeply. Average velocity, how do you do it? This is the PISA question. It's not difficult. While going, I'll repeat the distance is 6 kilometers. Time taken is 10 minutes. While returning shortcut, the distance is 4 kilometers. Time taken is 6 minutes. So, what is the average velocity of the child? That is a PISA question. Velocity, speed, time. There is a lesson. I do not know which class. Maybe 8th class, 9th class.
9th class, ma'am.
9th class. Who is saying that? 9th class किसने बताया? वकील सिंह जी.
नहीं, Sumit Chakravarti.
Sumit Chakravarti ji. So anyway, I will tell you the answer. You people are having this one our virtual platform. All will listen to me. I may give a wrong answer, but it is nice if you give wrong answers. I enjoy it because all of us give wrong answers. What they told was, now one AC got up and told, while going the velocity is equal to distance by time. Onward distance 6 kilometers. Time taken is 10 minutes. Kilometers by minutes. Okay, units and all don't bother. Let it be 6 by 10. While coming back, the distance is 4. Time taken is 6. So 4 by 6. So the assistant commissioner 10 by 6 plus 4 by 6, whatever he gets, by 2 because average. Is it correct?
No, it is not correct, ma'am.
Who said that? Sumit अरे कलकत्ता रीजन वाले आंसर कर रहे हैं. कलकत्ता रीजन जी आप बताइए क्यों करेक्ट नहीं है?
Ma'am, actually, average velocity is obtained by dividing the total distance by total time taken.
And Mr. Sumit, I want to give you a 5-star chocolate, but how to give virtually? Eat for yourself. I do not. That's the thing. Total distance by total time. 10, the onward distance plus return distance. The total distance is to be added, total time taken, that gives you the answer. So these are little things. While going on the road, just observe the right, left, and the structures there, the geometrical figures there, and relate it to your mathematical questions. Like now, recently COVID pandemic, the graph, how the cases have increased and decreased. In Arogya Setu app, I think all of you are registered. Every day I check the graph. I don't know whether it is becoming in radio FM is telling that the number of cases have decreased. Graph you can take and frame some questions based on the graph, which is related to the day-to-day. Of course, it should be in the syllabus. Shravan Kumar ji told it should be related to some learning outcome. So this is what we want, competency based, related to PISA, some indirect questions, applicative questions related to the surroundings of the child. And of course, there should be mathematical concepts involved in that. It is very, very difficult. You are not ordinary teachers. You are teacher plus. Training questions, our personal time, we have to waste 2 to 3 hours, sit near our table, and then you should have your own personal laptop. If you don't have, buy one, and then sit there and start framing questions and keep how to use the computer. Save all of them in folders and use them when required. Okay. Am I correct, Mr. Shravan Kumar ji? I hope this
Yes,
workshop, our Kolkata region people are here with us. Utilize them and make a notes. And at the end, I will get a report of this workshop. My resource persons are somewhere else. They will also give some lectures. Utilize this time. And thanks for inviting me for this inaugural session. Thank you very much. I have another meeting. Hindi, some workshop is going on simultaneously. I'll join in Hindi and I'll come back to you. When the resource timetable is given to me, you are always with me only virtually. Your link is with me. So anytime I'll join. Okay. Thank you so much, Shravan Kumar ji.
Okay, thank you.
Thank you, our resource persons. Thank you very much, all the participants. Take the attendance. 68, including me. 69.
Okay.
69.
Yes, sir.
Okay. Thank you very much, friends.
Okay, thank you.
Thank you, ma'am.
Thank you, madam. Thank you very much,
Thank you,
madam,
ma'am.
for giving the valuable inputs, direction for the training program. Thank you very much. Right now, it is 10 o'clock. Now, I request the resource person, Kusum Kumari madam and Chakravarti sir, to start the training on this topic, development of teaching material.
Thank you, sir. So first of all, I would like to thank Kendriya Vidyalaya Sangathan to give me this opportunity to train, to get the training as a master trainer, and further to deliver the things to the fellow TGT maths teachers. So first of all, good morning to our course director, sir, and all the participants. Our today's goal is to achieve one of the module decided under the competency-based learning program, that is development of teaching materials. So, am I audible to everyone? Because I have some voice.
Yes, sir. Yes.
problem.
Yes, sir, you are audible.
Audible, sir. Thank you, sir. So, our goal is to develop some teaching materials based on competency-based learning program. So, first of all, I think we all are agreed with the point already discussed by Honorable AC Ma'am and Course Director Sir, that nowadays teaching is not only delivering things to the students, transferring your own ideas to the students, and just taking the class in that way. I think nowadays we have to shift from the traditional method, and we started that. We are shifting from our traditional method, and we are adopting some new ideas so that students can be not only gain knowledge, not only be benefited, but also I think there must be some attachment between a teacher and a student, because nowadays so many materials are available in the online platform and all. So they are not only dependent on you. So when we do something in the class which attracts them, I think that is more important. Then to deliver the things in the same way as we have received in our own time. Because now, on that time, we didn't have much facilities, much resources. So we have to design the resources in such a way that they should get attracted towards it, and they should be given the opportunity to explore those things, and they can think at the end of the day कि अगर मैं स्कूल ना जाऊं तो ये फैसिलिटीज तो मुझे नहीं मिलेंगी. Otherwise, the traditional way, I think I don't find any traction among those traditional ways. So coming to the point, since we are today try to develop some teaching learning material, so the introductory part of that I'm covering. Then activity part will be taken up by Kusum Kumari ma'am, my fellow teacher. So mathematics in the classroom. Now see how the traditional things have been changed. In the mathematics classroom, students are exposed to opportunities that help them to develop and engage their mathematical thinking. When we were studying, at that time, teachers' mathematical thinking was much more important than ours as a student. But nowadays, we are thinking about their mathematical thinking. We want to develop their mathematical thinking, and we want to engage that thinking process. We have to do something by which we can engage their thinking process. Then solve problems and demonstrate their understanding. That is the second point. Means, I think solving problem is the major task. Learning mathematics in the class and dealing mathematical problem in the daily life, sometimes these things do not match with each other. So we must be very much careful that whether we are transforming the problems in transforming the daily life problem into the mathematical problem, then the solution should be acceptable to the daily life requirement. Like I want to take one small example. Suppose we want to fit some tiles on the floor. It is a 6th standard problem, I think. One question is there. The dimension of the floor is given. Dimension of a tile is given. So what we teach students that, okay, you just get the area of the rectangle and then you divide area of the rectangle by area of each tile, you will get the number of tiles. Okay, the solution is correct. But the thing is, in daily life, the number of tiles required is more than what we have calculated mathematically. Because it may be possible that the dimension of the room is not the multiple of the dimension of the tile. So we have to use some half tiles. So tile cutter machine is used. So while using the tile cutter machine, it may be possible that कुछ tiles खराब हो जाएं. So if we count that part also, then the solution will be accepted in the daily life environment. That means if 100 tiles are required, we have to purchase, I think, 110 or 115 tiles. Because it may be possible that while fitting the tiles, कुछ खराब हो जाए, कुछ को काटना पड़ जाए. So ये जो acceptability है, daily life environment के साथ, daily life के requirements के साथ, that acceptability and that type of idea should be inculcated in the mind of the student is very important. So that is what I want to stress on that. It is applying strategies and conceptual understanding in familiar and unfamiliar situation. Now, we give questions to the students always in the familiar situation. And sometimes what happens when unfamiliar situation comes, they get it impossible to solve. So I think we should explore them to the unfamiliar situations also. So as Honorable AC Ma'am has posed a question, that type of question may help you in that. Then recognizing the relevance of their experiences in their environment through a mathematical lens. वो जो observe करें, whatever is observed by the students, that should be seen through a mathematical, that should be taken in a mathematical way. We can share their experiences in the class, what they observe in the day-to-day life. Use and contact what they are learning to context outside the mathematical class. The context, because now the teaching is not only content-based, it is context-based also. Content तो है हमारे पास. If we have a chapter, the name is arithmetic progression in class 10th. So before solving the question, students know, yeah, arithmetic progression means we have to either find out the nth term of an AP or we have to find out the sum of the first n terms of the AP. Before solving the question, they know it because you made a heading that arithmetic progression is the chapter. But if we pose a question which needs arithmetic progression concept, but we did not declare the topic, that is arithmetic progression, they will think, okay, I think there may be some AP related concepts maybe. So that context is much more important than content. Content to hai, content is the part of the syllabus, but contexts are much more important there. So in all that PISA based question and all, they are actually context based. From context, we have to find out the content and then we have to deliver the things in that way. Now, the learning resources. In mathematics, we are having many learning resources, traditional. I think in the next slide, some photographs are there, pictures are there, where we find some traditional learning resources. To make the learning resources just for the sake of making it, I think don't play any important role in the teaching learning process. The learning resource should be taken in that way. The concepts of the student must be clear. They should be, they should get interest from there. So some of the resources which we can use for teaching mathematics, हम लोग हमेशा से use करते आ रहे हैं. The second number is very commonly used. That is number line. Then physical models. They are already available in the market. Sometimes we used to develop it. Geoboard. Nowadays, videos, presentations, real life object, and at the end, GeoGebra. So if we try to explore GeoGebra, I think the things will be much more interesting, and at the same time, we will find it easy to deliver the things what we used to do it manually. So you can see it from some pictures that these things we used to have it. Means whatever is declared in the last slide, they are displayed here. Physical models are there, number line, GeoGebra, GeoBoard, all these things we are using nowadays as mathematical resources. Some are traditional, some are new resources. So we have to think about that. By using these resources, how can we develop a better teaching learning material? That is the main content of main purpose of this particular program. So learning from resources is the important part. Means हम resource से learn करें. किसी लिखी हुई चीज से लर्न करने के बजाय अगर हम रिसोर्स से लर्न कर पाए, आई थिंक दैट वुड बी मच मोर important thing nowadays. So teaching of mathematics should enhance children's ability to think and reason, to visualize and handle abstractions, to formulate and solve problems. And that was means that idea is designed 15 years before. In NCF 2005, you will find it. And the page number is also mentioned here. Mathematical competencies common to NCF 2005 and ESA means communication, visualization, and connectors. How the things are connected. How one topic of a particular chapter is connected with another topic of another chapter in the same class. Horizontal connection. And how the things are connected vertically. From one class, we are transferring things to the other class. The ideas what we are using in class 8 that may be inculcated in class 7. We are just using the advanced form of those. So these are the things from where we can learn. So we have to have resources, the main target in such a way. Originality must be there. We will make materials which will definitely benefit the student. That should be the aim of our making it, not for saking of making resource material. If you just make it for saking, for sake of making it, then I think it is better to use the traditional way. आप अगर सिर्फ फोरम कंप्लीट करने के लिए कर रहे हैं, उससे बेहतर है कि आप ट्रेडिशनल वे में चले जाइए. If you are making it, at least some originality must be there from our side, some creativity must be. So I think this is the introductory part of this. So activity, ma'am will take up the activity part of this particular module. So Kushum Kumari, I welcome Kushum Kumari madam to take up the activity part.
Thank you, sir. Good morning to all of you once again. I hope so I'm audible to all of you.
Yes, madam.
Yes, yes.
Yes, ma'am.
Okay, so we will be doing an activity. I had already told you to take an A4 sheet. I hope so you all are having that. So let us begin our activity. Okay, so you all can see, you can pin my picture on your screen so that it is visible to you. So can you see this A4
Vakil sir,
sheet?
pin it. Vakil sir. Yes, yes.
What happened?
No, nothing. Now it is okay.
Yes, madam.
Okay.
Visible.
Okay, so I hope so this is visible. So you all can see an A4 sheet. Okay, you can take yours also. So what we are going to do is, our first step is, I want the largest possible square from this rectangular piece of paper. So how can I get that maximum, we can say largest possible square from this piece of paper? Can anyone tell? You can unmute yourself and tell your ideas. How we can get an...
By folding along edge.
Okay, by folding like this?
Along the edge. Along one of the
Diagonal.
Okay, by folding
not diagonal, it is a rectangle.
like this?
And fold from downward,
ma'am.
All of you make that largest possible square with your A4 sheet paper. Okay, so you can see we have folded it like this to get the maximum possible squares. Then we can remove that extra part by folding it once again. So I'm going to tear it. So this extra piece of paper can be set aside. You can keep it or throw it in the dustbin also. And now we are having a square piece of paper. I hope so you all have got it. Yes, I can see some people showing their square piece of paper. Okay, that's fine. Very nice. Lovely. Okay, now what I want the largest possible triangle from this piece of paper. So how can I get that triangle? Yes?
Diagonal wise you have to cut.
Just cut it along the diagonal, yeah.
So we can fold it and cut it along the diagonal to make that triangle also. You can do it. Fold it and okay. So now you can see that we are having two triangles with us. Okay. Can you find some similarity between these two triangles?
Congruent.
Okay, they are congruent. Okay. Now you can keep the other piece and take one of the pieces. And now again, I want two triangles from this triangular piece of paper. So what should I do?
Fold in the middle.
I can fold it along the median. Okay, this could be the median also. This is a median. Can you tell me which type of triangle we are getting?
Isosceles. Isosceles right triangle.
Yes.
Isosceles right angle.
Right triangle.
Isosceles right triangle.
Okay, so now what we are going to do? We are going to get two triangles from this single triangle.
Equilateral.
Larger triangle.
Equilateral triangle.
We'll fold it like this. Now, we'll tear along this line. Okay, so now we are here with two triangles. Okay, now we are going to name these two triangles. Okay, and then you can take a pen or a sketch pen or anything, and you can mark those two triangles. So I have marked one triangle as triangle 1 and the other as 2. Are all done with this? Are you still here? Okay, so now we'll keep and take the other piece of triangle. Okay, now the other piece of triangle. Now what I want is, I want to get a trapezium, isosceles trapezium and a triangle out of this piece of paper. So now, how do I need to fold it so that I can get a trapezium as well as a triangle? Okay.
Cut the vertex.
Yes, I can.
Hold it the vertex.
Okay, Pankaj sir is showing one method. Okay, hold it horizontally. Yes. Divyashri ma'am is also showing one method. So what we are going to do, we'll hold it from the tip of the triangle. and we'll fold it like this.
Now I will send all the question to you. Yes, I will put answer for you.
Okay, so can you see, I folded this paper, this triangular piece of paper like this. Now I'll clear it off, okay? Now let me clear it off. Now we are getting one trapezium. This is an isosceles trapezium and again an isosceles triangle. So now you can name this triangle as figure number. What will be the number of this figure? We have marked 1 and 2. 3. Okay, yes. So this I have marked it as 3. Now hold this piece of paper. Okay, and now from this piece of paper, this isosceles trapezium, I want to make two congruent trapeziums. So how do I need to fold it? How can I get two trapeziums out of this single trapezium?
Fold horizontally.
Okay,
Fold,
yes.
Vertically.
fold
Vertically,
middle.
horizontally.
Yes, yes. Very good. So we are going to fold it from the middle of this trapezium, right? So we are going to fold it like this.
One second,
Yes.
madam. Excuse
Yes,
me,
sir.
madam. Yes, I am requesting all the participants to mute from your side. Whenever you want to say something, just unmute and say, because when your microphone is switched on and it is giving noise from outside. Okay, requesting all the participants mute the microphone, your microphone. Thank you, madam. Kusuma, madam. You please continue.
Okay, yes, sir. So here, now you can see that we can fold it from the middle to get two trapeziums, right? So now we are again going to tear it from the middle.
Madam, they are not isosceles trapeziums, no, madam?
No, these are not isosceles trapezium.
Yes, madam. Okay, madam.
These are just congruent, right?
Congruent.
Yes, and we can see one right angle here. Okay. Now you can take one of the trapezium, and what we need to do is, now I want to get a square and a triangle from this piece of paper. So how should I fold it so that I can get a, yes, I can see Vakil said yes. Yes. Like this, so that we can get a square and a triangle. Yes. So fold it and tear it. So I have folded it like this. Yes, Vandana ma'am. No, you have to take only one trapezium. Okay. We are going to take only one trapezium, and out of that trapezium, we are going to get one square and one triangle. Okay, so we have folded it like this to get a square and a triangle.
Madam, right angle triangle, madam? Right
Yes.
angle triangle.
Yes,
Right angle triangle.
right angle triangle, and again it will be an isosceles triangle also. Okay. Now we are with one square and a triangle. So you can name this square as which figure it will be. We have already named 3 figures, right? So we'll mark this rectangle as figure number 4. So this is figure number 4, and we can mark this triangle as figure number 5. Okay. So I hope so I'm clear. If you are facing any difficulty, you can unmute yourself and ask.
Madam, will you please show this trapezium to square?
Okay, trapezium to square. What we did was, it was like this, right? This trapezium was like this. What we did, we folded it. Okay, the trapezium, we folded the triangular part like this to get a square and a triangle. It was originally like this. We folded it like this. Okay, we placed this vertex of the triangle to the vertex, other vertex of the trapezium.
Isosceles right angle it is.
Is there any doubt or confusion?
Madam, can you say from the beginning, madam? First square only. Second picture onwards, can you repeat, madam?
Second picture onwards.
First one is.
Activity program again.
Ma'am, you take one more paper to explain it.
I have already cleared the paper. Okay.
better, ma'am.
So, Sunila ma'am, can you turn on
Or
your
any
camera?
participant, not any participant can show it on our behalf.
Sunila ma'am, you are at which step? Can you please turn on your camera and show me?
Yes, yes.
Okay.
So first only over, madam. I took a A4 size paper.
Okay.
Then only first triangle part is over.
Okay. Clear it off. Okay. Here the triangles, the two triangles, along which you have folded. Any other participant can help Sunila ma'am in the next step? Okay, yes ma'am. Very nice. You have got now two triangles. Now you can keep one triangle and take one of the triangle, and from that one big triangle, you have to make two small triangles. Okay. So yes, you can take one and fold it along the median or middle of that. Yes.
Okay.
Yes.
Okay, ma'am. Yes.
Now tear it off. Okay.
Yes, madam.
Madam.
Anyone else has missed these steps? So you can see Sunila ma'am also. Okay, clear it off, ma'am.
Cut along the median.
Finish, madam. Finish, madam.
Why don't you present yourself now? Kusum Kumari, madam. If you present yourself, it looks bigger, madam.
Okay. So from that two pieces of triangle, ma'am. So you are getting from that biggest triangle, you got two more triangles, right? Now
Yes.
you can name those triangles as 1 and 2. Okay. Name these two triangles as 1 and 2. Sunila ma'am, I think you are getting confused.
So over now, madam. This is folded.
Please tear it off. Okay.
This one only I have to tear.
Yes, you have to tear from the middle. Yes.
Okay, madam.
Okay. Now you can name those two triangles as triangle number 1 and triangle number 2. Okay.
Yes,
Figure
madam.
1, figure 2. Okay. And now you can keep them aside.
Yes, madam. Okay. Yes, madam. 2 and 3.
Okay. So have you named, ma'am?
Yes, madam. 2, 3 is over.
Okay. Now you can place them and keep it aside and take the other piece of triangle, that larger one. The
Yes,
larger triangle. Okay. Yes. Now we want to find. Okay. I am having some other kind. So it's just like this. So what we need to find, we want to make a isosceles trapezium as well as a triangle from this triangular piece. So how can I fold it? I can fold it like this. Okay. So please fold it like this. Okay. Now tear it along this line you have folded. Tear it along this line.
Scissors.
Either you can use a scissor or you can.
Scissors. Yes, madam.
Okay, then after folding it, then you will get a triangle and a trapezium. Okay, so name that triangle as figure number 3. Okay, we have already named 2 triangles, and this is third figure, so we are naming it as 3.
Yes, ma'am.
Okay.
Figure number 3.
Okay. Now you are left with this piece of paper, right? This shape, this trapezium. Now from this single trapezium, I want 2 trapezium. Okay, 2 congruent trapezium. So how will I fold the paper? I'll fold it from the middle, right? Like this. Yes. Okay. So now tear it from the middle so that we can get 2 trapeziums.
That corner also you cut triangle, madam. Left side corner. Another, no, not that one. This side. This side.
This side.
That one also you get so that you will get trapezium.
Yes, we can also
No,
fold
madam.
it, but we will get then a triangle and a trapezium, right? But we need to find 2 trapeziums, right?
Trapeziums.
2 trapeziums.
In the middle you fold for 2 trapeziums.
Yes.
In the middle you fold.
We will fold it from the middle, okay?
Then you will get 2 trapeziums.
Yes. Now cut it along this line.
Along that line.
Cut it along
Along
this
that, please cut it, madam. Cut it. Now take one and the triangular part you cut. That this edge triangle that fold.
Okay, now from this trapezium, I want a square and a triangle. Okay, so what will I do? I'll fold it like this. Okay, I'll fold it like this and tear it along this line. Okay, I'll tear it along this line. So we have reached where we have done. Okay, so we have. Okay, yes, ma'am. Now cut along this line. So we will get a triangle and a square.
Square.
Yes. And now cut it, ma'am. You haven't cutted it, I think. Did you tear it? From the trapezium, you have to get a triangle and a square. Okay. Okay, done. So name the square as figure number 4 and the triangle as figure number 5. Okay. It was something like this, right? So we folded it to get a square and a triangle. So we have named this figure as figure number 4 and figure 5. Okay. So now we are left with the other trapezium, right? We are still having the other trapezium. Okay.
Yes.
Okay.
Yes, ma'am.
So, now from this trapezium, I want to.
Excuse me, madam. Excuse me, madam.
Yes, Bharat.
Excuse me, madam.
Yes.
Madam,
Sir.
video problem, madam. I'm not able to see video.
Then pin it, sir. You select the madam and pin it. Pin is there now. You select that one, then you can see.
You can pin my video.
Madam ka ID hai na? Madam ID you just pin karo, then you will get.
Yes, sir. I could see now.
You will get. Yes.
Thank
Okay.
you,
Proceed.
thank you.
Proceed, madam.
Okay. So now, what we have to do with the other trapezium? We want to find a parallelogram and a triangle. So how can I fold it? How shall I fold this paper? So fold this trapezium so that I can get a triangle and a parallelogram.
This 90 degrees edge, just cross triangle, you fold it. Parallel you will get.
From here?
Yes.
Okay.
Yes.
Okay, so all of you can hold
Yes,
this
now it
piece
is
of
parallel.
paper. Yes, exactly. We will do like this only.
Here, ma'am.
Sunila ma'am, did you get this? How we'll fold it?
No, madam.
we were having the trapezium, right? We were
Yes,
having
yes.
the trapezium.
Yes,
We
madam.
want to find a parallelogram and a triangle. So what I did, I took one corner and folded like this. Okay. So now you can see here a triangle and a parallelogram, right? Is it clear to all of you?
Yes, ma'am.
Okay, then tear it along this line also.
Video is off. Video is not.
In the parallelogram.
Okay, yes. So now we are here with two more figures. One is parallelogram and one is triangle. So you can name this parallelogram. Which figure
Parallelogram.
number? Yes, this will be figure
Parallelogram.
number, and this will be figure 7. Okay, you can name this parallelogram as figure number 6 and the triangle as figure number 7. Okay. So now we have finished with what we have started with. Okay, we had a big square. Okay, from that square we made two triangles. Then from one piece of triangle we made another two triangles, and then from the other piece of triangle we made these figures. This is how many total pieces we are having?
Seven.
Okay, so 7. These are the pieces of a tangram. Okay. So can you name the figures? What is the name of the first figure, second figure, third figure? And you can write it in the chat box. Let us see.
One is triangle.
Yes. So you can just check out your figures. You have already named them. So let me show you. Okay, figure number 1 is a triangle. What about figure number 2?
Same isosceles triangle.
Same isosceles triangle. Okay. Figure number 2 is also a triangle. Then what is figure number 3?
Right angle isosceles.
Okay. Figure number 3 is again a triangle. What about figure number 4?
Square.
Figure number 4 is a square. Okay. What about figure number 5?
Right angle isosceles.
Okay. Again a triangle.
Right
Figure
angle.
number
6 is parallelogram.
Okay, 6 is parallelogram, and figure number 7 is again a triangle. So these are the 7 pieces, or you can say 7 tens of a tangram. You might have heard the word tangram. Okay, so from now these pieces, 7 pieces, can you make the original square that we started with?
Yes,
Let's
sir.
started with a square. Okay, so using these pieces, can you make a square? And you can send the pictures in maybe WhatsApp group.
Ma'am, can you just repeat the last step of parallelogram?
Okay, last step of the parallelogram. Okay, sure. So we were having a piece like this, right? We were having a trapezium. Okay. Now what I want a triangle and a parallelogram, right? So what I need to do, I need to fold it along some line. What I did, I folded it like this. Okay. From you can see one tip of the trapezium to the other tip. You can fold it like this. Then you can get a triangle and a parallelogram. Is it clear, ma'am?
Yes, ma'am, I got it.
Okay.
Thank you.
Okay, so can you all make that square that we started with? Have you all made it? Okay, once you have made a square, can you try to make a rectangle with these 7 pieces of tangram? You can send your pictures on the WhatsApp group also after. and a rectangle.
Ma'am, parallelogram is to be marked as 6 and triangle as the 7, no?
Yes, yes. Parallelogram is 6 and the triangle is 7. Manjulata ma'am has sent one picture of square. Nice, ma'am. Okay. Now, we've got one square, and can you make a rectangle using these pieces? Okay, so we have received one rectangle also. We were not supposed to use that. Okay. Okay, from these 7 pieces. Okay. Why send this rectangle? Can I know the name?
Lakshmi Kumari.
Okay. Thank you, ma'am. Okay, can you think of making an arrow with these stands? Can you make an arrow? We have made a square. Okay, thank you, Lakshmi ma'am. Okay, we have received another picture. But sir, you haven't used all these stands. Okay, you have to use all these 7 figures. Whoever has sent this rectangle.
Narendra sir.
We have to use all these 7 pieces, right?
Got it, ma'am. I will do it.
Okay. Yes. Is somebody saying, Suresh sir, are you saying something?
No, no, no.
Okay. Yes, I think arrow, we didn't get an arrow. It's difficult to make an arrow, right? But we can make. Has anyone made an arrow using all these stands? Okay, you may try. Okay, no problem at all. Okay, we have got one more figure. Did anyone make an arrow?
Yes, ma'am, I have sent.
Okay, Manju ma'am has sent. Okay. Very nice, ma'am. Okay. So now we have also we have got an arrow, a rectangle, a square. Okay. Now, can you think of any figure that you can make using these stands? Any figure. Maybe it could be a human being, a cat, or anything.
పేపర్స్ వాళ్ళ మెటీరియల్ రెడీ పెట్టుకోమని చెప్పారండి A4 షీట్స్ కావాలంటే అక్కడ నుంచి వచ్చేస్తుంది.
Okay, we have received another arrow.
టైం పాస్
Okay, I think I can see one picture. It is in the shape of a rocket. It is shaped like a rocket. Okay, very nice. Is this a Christmas tree? When Kat sir has sent, I think. You can make a different figure, different from a rectangle, an arrow, and a square. Any figure. Okay, Dia ma'am has sent one. I think it's like a human figure. Very nice, ma'am. Okay, so we are getting so many pictures. Okay, so you can think of more pictures like this. You can think of making so many pictures using all these stands. One question I need to ask you. So how many total triangles were there in the figure? The total 10. We have made 7 pieces, right? So how many triangles are there?
5 triangles.
Okay, so we have 5 triangles. Okay, can you see some similarity or difference between these triangles?
All are isosceles triangles. Isosceles right angle triangles.
All are isosceles right angle triangle. How can you say that?
Similar, ma'am.
They are similar. Okay. All the triangles are similar. All the triangles are right angle, isosceles triangle. Yes.
All triangles are similar, madam. Similar is there.
Okay. All the triangles are similar. So, if I want to find the ratio of the area between the smallest triangle and the largest triangle, can we find it? Can we find the ratio of the area of the smallest triangle and the largest triangle?
1:4.
1:4, madam. 1:4, madam.
1:4.
1:5. Can you prove it? Can you prove it? We are having the largest triangle. Okay, I have taken maybe triangle number 1 and the smallest triangle that we got was triangle number 7. So how can you prove that the ratio is 1:4? Yes, Vakil sir, you want to say, you can.
Like this.
Like this, madam.
One, then
Okay.
rotate like this.
Okay.
Two, then similar this way.
Then you will get a square on that.
Three.
For one side it's enough. No, anyhow they are similar triangles.
Similar.
One side is enough. Yeah.
Yes.
Yes.
They are. This part is 2 and similar this way.
Okay. Yes. Definitely. Vakil sir, you have explained it very well.
A by 2 whole square is to A square, madam. That also can take. A by 2 whole square is to A square.
Yes.
That is A square by 4 is to A square. 1:4 will come.
1:4. So the ratio of the smallest and the largest triangle is
1:4.
Fine. Okay.
So, madam.
Yes. Yes, sir.
Madam, can I add something to it?
Yes. Yes. Definitely.
Actually, when we are dealing with similar triangles, we know that side area relation. So from there we are getting the ratio 1:4. Suppose the same thing you want to explain in class 7, where they don't know about that side area relation of similar triangles, then how will you justify it? 1:4.
Or since it is a right angle triangle, here you can say directly, no, sir.
Using this activity only we can do it.
Pardon, sir?
By
Sir, with
using,
the same activity, already sir, with the same activity we can prove, no? Because if you place one triangle on the other, you are getting the side is double of the other arm.
Okay.
Since they are right angle triangles, you can apply the formula.
Suppose we are not doing this activity. For example, we are having this small triangle and a bigger triangle. Both are similar to each other. And then we want to explain that the side area ratio of their areas is 1:4.
By folding, we can explain, sir.
Base is becoming half.
By
Base
folding
is becoming half and height is becoming half.
Yes.
like this foldings.
Not to go for theoretical proof.
Yeah.
Here, like foldings. One,
If
two,
you
three.
join the midpoints, no, you will get that one only, no? If you join the midpoints
Or
of
I
three
think we can do one more thing, that we can make 3 identical triangles of that small triangle and
you
put it
place
on the
on that
larger
one,
triangle.
yeah. No, that's why, sir. If you take 3 midpoints, you place it, then automatically this will suit their
Exactly.
creation.
Exactly.
Yes.
That I wanted to add, because sometimes the same concept when we teach in small classes, then it is difficult to use the theories we know. We know it because we are the teachers, we are teaching up to class 10, so we know all the concepts, but children may not. So sometimes we have to give the simpler explanation of the same thing. Okay, Kusum ma'am, continue please.
Yes, sir. Okay, the next question is that we have made a rectangle, a square, an arrow, and so many different figures using these all pieces. So, what can you say about the areas of these figures? So, are these areas different for different figures, or they are having same? You have to give an explanation. Okay, if their areas are same, then why? If they are having different areas, then why? Okay.
Areas are proportional.
Okay, Vandana ma'am, you are saying areas are proportional.
Like the triangle number 2 and the square number 4.
Okay. No, I think I'm unable to explain the question. I want to say that you have made the triangle, you can say the square using all 7 pieces, right? Then you made a rectangle using all those 7 pieces. Then you also made an arrow and some other figures also using these pieces. So what can you say about their areas? So are they having different
areas? They will differ. No, they will differ, madam.
Having some relation between, yes, Srivali?
Areas are equal.
Okay.
Boundary is different.
Okay, areas are equal. How can you say that, ma'am?
No, areas are not
Area
equal.
is the place occupied. We use the same sheet of paper, no? So on that concept, areas are equal, but boundary is the external this
Perimeter. Okay.
So due to the
Perimeter
arrangement,
is different, madam, but area will be same.
area will be same,
Because all the
boundary is
pieces,
different.
Okay.
because
So,
all the pieces are joined together to make any figure.
Jayashankar sir, yes, right. Okay. Madhav sir, you are saying also something?
Madam,
Yes, sir.
area summation axiom. The sum of the whole figure is the sum of the individual areas. Can we say this is an area summation axiom, madam?
Sir,
Sum of the areas of individual figures is equal to the total area. It remains unchanged. It is area summation axiom. We can say for class 10 children.
yes.
So one more thing. From this, you can say that congruent figures we have same area, but whereas the areas are figures with same area are not congruent.
Okay. Yes. Yes. So from these figures that we have made using all these 7 pieces, you know that we are using the same pieces of tans to make different figures. Okay. So the area is definitely going to remain the same, right? It is the space occupied, or we can say the region occupied by the figure. So since we are using the same pieces every time, all the 7 pieces, so the area of the whole figure will remain the same. Yes, definitely they will have some different parameters. Okay. Can you say something about their parameters? Can you find some relation between their parameters? Is there
Perimeters are different.
Okay, parameters are different, and
They are not
it is,
same.
yes.
Parameters are different.
Okay, parameters are different. Okay. So my next question will be, if I take the area of the smallest triangle as 1 square unit, okay? If I take this area as 1 square unit, so what will be the area of that original figure, that original square that we started with? We were having, if I take this as 1 square unit, what will be the area of that square that we started with? Can you find it?
Small triangle one.
32 times of the smaller one.
Madam, 8 square unit?
8 units, 8 square units.
8 square units.
8 square unit.
8 square
What about
units.
others?
Madam, it is 8 square unit.
32.
Manju ma'am,
The
you are
area
saying-
of square is 32 times the area of the small triangle.
Okay, 32 square units.
32 times.
Okay, can you explain how we are getting 8 square units?
Because just now we folded the bigger triangle with the
Ma'am, I think it is 16, madam.
smaller one, na? 1:4.
Hmm.
So the bigger triangle is making a.
I'm asking about the square
Okay,
that we
16.
started with, that big square. Okay, from
16,
Ma'am, I think 16, madam, it is.
16 it is.
16 it is. Yeah.
16.
See, ma'am, from this triangle we can make 4 equal triangles. 4 in the triangle.
Yes.
For square 2. Okay, ma'am. Again from here 4. From here 2. From parallelogram 2. And remaining 2. Total 16.
16, madam. 16.
Yes.
It's coming 16.
Yes.
Yes,
So
ma'am,
the total
16.
area of that figure that we started with is 16 square units. Okay, so if we take the unit area of the smallest triangle as 1 square unit, what if I take the area of that figure number 1 as 1 square unit? So what can you say about the area of this square? If the area of this figure number 1 is 1
Half
square
of it,
unit,
madam.
the area of this
Half of it. Square is half of it.
Half area. Half area.
Half.
Area of the square is half of area of the triangle.
Yes, ma'am.
Because there are 4 triangles, here 2
This
triangles.
is by midpoint.
No need of midpoint, ma'am. There are 4 triangles. Here 2 triangles.
Yes, sir.
Okay. So we will get some fractional values, right? If I take the square area of the larger square, figure number 1 as 1 square unit, and I'm trying to find the area of other, then I'll get some fractional values. We can say like this. And if I take the area of the smallest unit, then I'm going to get some whole numbers, right? If I want to find the area of any of the figures, right? Okay. So, can you find the perimeter of that original square? I was telling you that the side of this smallest triangle is 1 unit. If I take this as 1 unit, so can you find the perimeter of the square?
Which square? Which one? Which one?
Which triangle you have taken, ma'am? Which side is one? Seventh one or the third one?
This isosceles part 1. Okay, this is one.
Legs, madam, legs of that triangle.
Or root 2, I think so.
Please repeat, sir.
So, madam, this one has 1 unit. This one, which one? Hypotenuse has 1 unit.
That isosceles, the two sides which are equal.
Legs of the right
What's the
triangle.
number of triangle?
8.
4 units.
8.
4 units, madam.
8. Perimeter 8.
8.
The perimeter of that square, that big square that we started with.
4.
The small square or the big square, madam?
12.
Big square, the big square with big.
The original square.
Yeah, okay.
4 square unit.
8, ma'am.
12.
Ma'am, 12, it's 12.
Why we are getting different answers?
9, is it 9?
Yes. Vandana ma'am, you have raised your hand. You want to say something?
Oh, ma'am, I think by this.
Okay, okay.
Six units is coming. 6.
6 units.
Yes, ma'am. Perimeter.
Okay.
I think perimeter should not be so small.
12.
8 root 2.
12.
Madam, one small dot here.
That original square, that big square that we started with. Okay.
12 centimeter.
So, madam, you are taking small triangles. This side has 1 unit, right?
12,
Yes, this side has 1. Okay, that we can say the legs.
Yeah,
Madam, 90 degree making. 90 degree making.
8, ma'am. It is 8.
Small triangle has 2 triangles. Isn't it?
It is
8 root 2, madam.
Lata
Like
ma'am,
this.
8, ma'am.
8.
It's 12, madam.
How you are getting 8? Can you please explain your answer?
Ma'am, this is square. It
If you take the figure what you have sent in the
is
serial
1
group,
unit, no?
if you see there,
So
if you take the figure, directly you will get 8 units, ma'am. You just see this figure.
Okay.
this figure, when we keep here, ma'am, and you know, this same, you know, if, in square, if we are keeping also, this exactly, no, it will fit this base. So 2 triangles we are getting. So 1 unit and here 1 unit, it is 2 units we are getting. So side also we will get to the same thing, 2 units. So area of this one will be 8 units.
Perimeter.
Sorry, perimeter. The perimeter of square is we have no 4 into side. So each side we are getting 2.
Okay.
4 into side.
You are telling me the area of that the square which will be formed by figure number 1 and figure number 2. Okay.
Yeah.
Yes.
Yes.
It's nothing but
Yes. 1 and 2.
16.
Okay. This will be 8. What about the largest square with which we started with? You can see.
largest, shall I go, madam, this largest one, you go
This is only largest square, no, ma'am.
smaller triangles.
Hmm.
This one is exactly equal to smaller. After getting the last one, it is equal to the smaller triangle, whatever we made it. Then when we unfold and see, and if we consider the side length, this as something A, okay, it is not an equator triangle. If you consider this as a something A, okay, then 4A will come, I think. Because here you are getting 1, 2, 3, 4, okay, and yet each side is having two parts of this smaller triangle. Yeah.
But Sirisha madam, you are considering A as the hypotenuse there.
A is this bigger part I consider because it is not an equilateral triangle. No, it is an isosceles
No,
triangle.
madam, no, you are considering hypotenuse as A, but you are not getting hypotenuse in outside, no? Along the boundary.
Yes, yes, hypotenuse we have to find out. If you consider side length as something A.
Okay, if we are considering the hypotenuse, okay, then we are getting, okay.
Then we'll be getting 4.
Okay, that's fine. Okay, thank you so much, ma'am. Mr. Would you like to ask some more questions?
Yes, ma'am.
You may ask more questions.
No, I wanted to discuss one thing.
Yes, sir.
Before that triangle perimeter problem, we discussed that area problem, no? Where we have taken that small triangle's area is 1 square unit. And some answers were coming like 8 square units and 32 square units. Suppose the question is asked in MCQ, I think any student without observing anything can answer 16 square unit if the options are 8, 16 and 32. Because see, 8 and 32 are not the perfect squares. So it was quite sure that any perfect square answer will come. So the answer would be 16. Without counting also we can get if that is coming in any MCQ question. 3 options are there. Without observing anything because only one option is perfect square.
16.
So it is apart from our topic. I wanted to share the distractors in the MCQ. Suppose you want to ask such type of questions, you put all the answers perfect squares. Then only the student will count it. Otherwise, he will simply put 16 as an answer because एक idea है कि 16 perfect square है तो यही होगा. 8 और 32 तो perfect square नहीं है. That I wanted to add with them.
But that is only possible only when the side is 1, no, sir. And the area is the perfect square. When the area of one perfect is 1, then only you can get that one.
So here the 1 unit area was 1. 1 unit triangle's area was taken as 1. It will not be any non-perfect square number as an area. So it was 8 and 32 can be rejected directly in this particular case. So that I wanted to share with you. Okay, continue, ma'am.
Okay. So in the similar way, we can ask some more questions. Okay. I'll show you some questions. Some of the questions. So this is the questions we have asked you. These questions could be framed and asked.
I just want to add to
Yes.
want to say something.
Yes.
Yes. Related, we gave for the half yearly under the part C some we divided in the examination into whatever 40 marks are 80 marks 40 marks are there into 4 parts. That part we gave this 10-gram work only. In this we asked all these questions like using 10-gram pieces. What are the educational related models can be made? Okay, or sort of objects like cat, children, whatever they like, something dog, cat, or kite, arrows, whatever you said, that also.
That's very good, ma'am.
You can use Arvind toys. Arvind toys you can open.
Toys, children, they made way for the education purpose. Some sort of geometrical figures you can go for making. Ultimate purpose is children with these pieces they have to learn some sort of education related. So we gave under the for the examination this work. Yes, ma'am.
Yes, ma'am. Definitely 10-gram pieces are very useful to, explain so many concepts. So these are the different shapes that we can make using the 10 grams. We can also make a triangle. These
Ma'am,
are the,
you are not using all 7 and only 5, 6 you are using. Just
yes.
go back. Just go back.
Oh, okay.
Just go back, ma'am. The previous page. Previous page. Slide. Just go to previous slide. Here you see. First
Yes.
one. No, ma'am. Next. No, some figures you have shown, ma'am. There.
Okay. These figures.
No. Yeah, before this page.
This one.
Yes. Here you are not using 7 in the first one. You are used only.
We haven't so that's why I don't ask you to. I don't ask you to make a triangle with that all the pieces. I asked you to make a square, a rectangle, and an arrow using the all the pieces of the 10 grams. Here, definitely, we are not using all the pieces of the 10 gram. You can see here, we are using parallelogram, 3 triangles, and 1 square.
Square.
We are not using all the pieces of the 10 grams to make
That
this.
means conclusion is by using all these 7 pieces, we can't make a triangle.
Try, sir. We will try.
Yes, of course. You can
try. Because we have tried, but we didn't make. That's why we did not give you that task.
Okay, so these are the other figures that you can make. So now coming to the 10 gram as a resource, we can say the topics which can be addressed using the 10 grams. Okay, so we can tell about the concepts of ratio and proportion, similar and congruent figures, area and perimeters. Okay. So these are the various ideas that can be discussed using the 10 grams. Like we can say in area and perimeter, which tan can be selected as a unit and why. So I asked you to take the smallest triangle as 1 square unit. Okay. So that we can get the area of other figures in whole numbers. Okay. Then we can say that why is the idea of unit important for learning area or perimeter. These points also can be addressed. Reorienting the parts of a shape does not change the area. So that is also we discussed that as we are using the same pieces of 10 grams to make different figures. So the area is not going to change. Definitely the perimeter is going to change. Okay, and then we found that there is no fixed relation between increasing or changing area and perimeter. So how we can give some variation in the questions? We can ask them to manipulate the objects. Okay, they are able to justify the resource. Using the resources, they are able to justify how the area of one figure is double the other or half of the other, and we can increase the level of complexity by asking simple questions. We can move towards higher order questions. Okay. So this will be the task that you have to do in your group works. Okay, you have to design a worksheet using a resource. You can take any resource. Here we have used a 10 gram. You can use either GeoGebra, GeoBoard, or some other physical model. We have discussed so many resources, so you can take
it a screenshot.
Yes, you can take the screenshot of this.
This is work for group. It is group work, madam. Kusum,
Yes,
madam.
yes, sir.
It is today's group work.
Yes. So, sir, please explain the task.
Actually, I am sending a screenshot of this first. The task every group will make means a worksheet using any resource you want. Resources already have been suggested. 10 gram we have shown. You can use GeoGebra or GeoBoard also. And you have to frame series of questions within your own resource. And you have to explain it within 15 minutes of time. One group will get 10 to 15 minutes time because we are having, I think, 7 groups, sir? 6 groups.
6 groups. We have
6 groups. So if we present it in 10 minutes, then it will take 1 hour and more. Means almost 1 hour, 15 minutes or 20 minutes to represent. So 1 or 2 group members can explain the things. So yeah, that you can decide among yourself because you have already framed the WhatsApp group of your own groups. So there you will discuss who will represent and all, and one resource we will see from each group, and 2 persons, at least 2 persons will present. One can share the screen, another can represent. That is up to you. You will tackle the things. Questions must be there, and that should be related with the topic, not be beyond the topic. So that is the task for today. So after this particular session, the session is about to end. After this, you can have a meeting and you can decide the things among yourself. So Kusum ma'am, what is the re-reporting time? Again with this link, 4:30, I think.
4:30, I think.
Before 4:30, you complete all the things. We will call upon groups one by one, randomly. Actually, it is suggested that we should ask randomly. So it may be possible that group number 6 can be asked first to represent. So all should ready before 4:30.
To make sure that
Sir.
So there are 2 sessions: individual work by participants, that is session 2 from 12 to 1:30, and another session interaction and group work by participants. Just give the people overview of what to do, what they have to do, so that they can do.
Means that in the first session they will decide what is to be made. That is, and in the second one, what is to be made and the individual work assigned. उस समय वो काम कर लेंगे और उसके बाद दूसरी बार जब वो मिलेंगे आपस में अपने ग्रुप में, when they will meet again, then they will finalize the things, the final presentation. Before
final presentation from 4:30 to 5:30.
Yeah, sir. In this link only.
Okay. So remaining 2 sessions are their individual sessions.
Yeah, sir.
They have to,
we will not join those 2 sessions.
Yes, sir.
Middle 2 sessions we will not join. We will join at the end to see the final presentation.
Okay, sir.
4:30 will be the presentation part. So each group will present one. I would suggest that if you can develop, the individual participants can develop their own one resource, okay, and you can frame questions. And in your group work, you can select the best one of your group, and that can be presented. Okay, so in that way, all will get the opportunity to make the resources.
And I request to all the participants.
Which one is best?
It's up to you. It's up to your group how you are going to manage. But at least one presentation from each group has to be presented at 4:30.
And request all the groups, please submit the whatever presentation you are doing to in soft copy to the school or ours, so that we can collect and we will compile at the end.
So, any more queries or any doubts regarding the tasks assigned? Anything you would like to share?
Madam.
Yes, sir.
You want us to take one content, and based on that content, we have to frame the questions.
Yes. You can choose one resource, okay, and you can think of which topics can you teach the students, or you can discuss with the students with that resource, and you can frame series of questions, some maybe 6-7 questions, or maybe at least 5 questions. You can frame, and then you can present it.
In the group, suppose
Questions. So is it multiple choice questions or direct questions?
It's up to you, sir. You can choose any questions.
all the people have to take their own resources, then from that the best one should be presented. Is it not?
Yes, that could be done. Okay, that depends on your group, your teamwork. How would you like to proceed? If you can
we need at least one presentation from one group. That is the target at the final representation. So I think we can conclude now.
Yes, sir.
Attendance work, I think, sir, attendance.
Yes, we are taking attendance.
Okay.
It is done, sir. Complete. Attendance हो गया, sir.
Okay then.
Okay, thank you, sir. Thank you very much. And again, we will meet by 4:20. All of you requested to join in the group with the same link. By 4:20, all of you join, and we start sharply by 4:30 because there are 6 groups. It takes time. Okay, thank you, sir. Thank you very much.
Why you have chosen charts of this, sir?
Okay,
Can Narendra?
421. 421.
420 is charts of this.
Okay, 4:21.
421.
Okay, thank you.
Thank you all the participants. Thank you so much.
Thank you, Kusum.
The intention is 10
Thank you,
minutes
sir.
before. Before time.
Thank all the participants for behaving.
Okay, thank you.
Okay. Sir, group A, sir, I will send the link. Please join the group A. We will have a meet. Ramji, sir.
Yes, I'm ready.
Yeah, I will send the link, sir. Please, we will join there.
Narendra sir,
Right, sir. Right, sir.
please
Thank you.
send so that we can discuss.
Yeah, no, that's fine. Yeah, sure. I will send to our group. Okay. Yeah.